Okay, right I have here is a power supply for a Model 1 TRS-80 that was purchased in 1978, and then over here I have the expansion interface of that. And what I wanted to do is just look at some of the signals coming out of this. Again, this was a see it there. I'm going to set this down, but right down in this area here you can see the voltages. There's one that's for the DC 19.8 off of pins 2 and 4, and then 1 and 3 was 17 volts AC. And over here is my best guess of the schematic for that, of this design here. So what I'm going to do now is I'm going to put this back here, and then in here the expansion interface. Alright, I wanted to mention one thing. I got these marked plus 5, plus 12, and minus 5, but that's not really the voltages you're going to measure across these capacitors. That's the input of the circuit that it feeds. So the output will be 5 volts. So these will actually be higher if you actually measure the voltage across these. There's a 220 microfarad underneath this guy right here. If I can pull it off, there you kind of see it there. So anyway, I just wanted to clarify that. So these are not the actual voltages, but this is the inputs to the this capacitor is the input to the plus 5 circuit. This capacitor is the input to the plus 12 circuit, and this capacitor is the input to the minus 5. So they will read higher voltages than what I show here. Just wanted to clarify that. What I'm doing for the signals is I'm tapping it off the switch right here. Right now I don't have power on, so I'm going to just, that's on and that's off. So I'm looking at it before it goes basically an open load on this guy right here. And I'm going to be looking at both the AC side and the DC, but what happens here is, as this comes in, there's a full bridge rectifier IC here. I think it's an MDA 202, and then this will actually be a rectified signal. And that feeds the 5 volts and the minus 5 volts. So the AC comes in, then 17 volts AC goes through this full bridge rectifier, and then it is used for the minus 5 and the plus 5 volts. Now the plus 12 comes from the 19.8 DC of this power supply here. So in the end, everything is DC, and it's a little bit safer for me to look at the signals at this end, so because it's kind of hard to get pins in or leads in here without shorting stuff. So I'm just trying to look at it on the board right here. And this guy right over here is the doubler, Percom doubler for the floppy drive that plugs in. So, alright, let's get to the signals, how they look. Okay, I also did something here, is I got white on one side of this because I'm finding a difference in the how the signals are being rectified when it's open. And the white is the neutral, so the larger blade here is the neutral. So I'm going to first plug it in this way. So what I'm going to do is first look at this, get it set up on the scope here. And I'm going to plug it in with the white side going to the neutral side here. Alright, you'll see it there, and you got pretty two clean rectified signals, which is good. And the top one is 20.5 RMS, and the bottom one, they're both about the same. The RMS coming out of the 17 volt AC and the 19.8 DC circuits. So now what I'm going to do is flip the leads here. I can show, if I can put this a little closer here. And this is really what I wanted to show, is how the signals. Now I'm just flipping it in here because it's not polarity here. Now if you do it the other way, this is the signals that I get. Now it's not quite as clean looking rectified. Again, this is open circuit on the power supply. And the voltages are a little bit higher, 22.56. And this one's even higher yet, 25.42. So that's kind of what I'm observing right there. So, alright, the top signal is the DC coming out of the power supply, and the bottom one was the AC coming out of the power supply that's rectified in the board right away. There's that diode right there, right by the connector there, or 4 diodes. It's a full bridge rectifier. So now I'm going to just flip the signal here again. Rotate it here. And then again, you got a pretty clean signal there. So what I'm going to do next is actually put in the other power supply just to show that it's similar but slightly different waveform. Yeah, I got the other power supply, the one with the rubber band. This is the one I cut open thinking it was bad, but it wasn't. That was another issue in the Model 1 itself. So now I have this on, and I'm going to see if I can show the signals there. Okay, I'm going to plug it in. So I've also marked this one with a white, and that's the side I want on the neutral side to have the cleaner signal. So here we go, and there you go again. You have pretty good rectified waves. Again, the top one was the DC, the 19.8, and the bottom was the AC, 17 volts, but it's, again, it goes through that, the AC goes through that rectified, full bridge rectified diode before it goes through the switch. So that's why I'm seeing it rectified. Alright, let's see the voltages. And a little bit higher than the ones on the other power supply, 20.6. And this one's a little bit higher, 21.5. So yeah, there they both are. Alright, now I'm going to rotate the polarity of the AC plug in this power supply. So now the white is actually going to the hot side of the switch, and there you see another slightly deformed signal over there. Doesn't look quite as bad, but and the voltage is there, 21 and 22, a little bit higher again. Alright, now what I'm going to do is just turn on the switch, and I'm going to do this with it off, of course, because everything's open. Alright, now I'm going to turn the switch on. So now I'm going to have capacitors on it. Alright, and now I'm going to plug this in so that the white is on the neutral side, which is the better performance. Okay, I heard the relay click, and let's take a look what we have now. The top one is, well, I'm going to just read the high voltage, which is like 26.8, which is pretty close to the RMS too, and the same thing with the other guy, 26.4, 26.6. Alright, now I'm going to reverse them. Back here. Reverse the polarity. Heard the click again. Take a look. .8, 27.2. So not a whole lot of difference. So I think in the end it's probably a don't care on the polarity, but it was just an observation that I noticed that it's not symmetrical on the way you plug in the AC on the Model 1 Radio Shack power supplies. Okay, I'm going to now put the other power supply in and just verify the same thing. Alright, I have my other power supply now I'm going to take a look at. There's the plug. AC plug. Now again, I'm just going to, I do have this switch engaged on, so now I'm going to put the white where I had the better performance on the neutral side of the, which is the larger slot here. Alright, I heard the relay click on. Let's take a look at our signals. And the DC signal on top is, that's reading 26.8, and the AC rectified signal, the 70 volts AC rectified, is reading about 25.6. Alright, I'm going to now switch it out. Rotate. Okay, I heard the relay click again. Now let's take a look. .8 and 25.6. So overall, I don't think it really matters which way you put it in. It's just that it was an observation that plugging it in between these two power supplies are not symmetrical.